No.
Thank you, Brandon. Cameron,
Yeah.
do you have any questions about the assignment?
Um, so it's about square roots. Is it about that equation specifically?
It's a, so I'll just reiterate, you're creating one Google slide or even one piece of paper. You can do that and take a picture of it and upload it to Google Classroom of the 4 ways that you've learned to solve quadratics. You need to include examples and you need to make it as detailed as you would need it if you were going to solve quadratics 1 year from now. So you don't do anything in math for a year and then all of a sudden you're confronted with quadratics again and you remember, oh, I have this piece of paper that I did and it's my cheat sheet that I'm going to carry forward to geometry and algebra 2. You're not going to do as much with quadratics in geometry, and Ms. McMunn can speak more to that. But in algebra 2, quadratics is going to be the very first unit that you cover. So it's going to be very important that you put this piece of paper in a special place and you keep it or file it on your computer and you keep it so that when you do get into algebra 2, you'll have your cheat sheet and you'll be able to remember not only how to do it, but the way that you created your cheat sheet, and it'll jog your memory.
So
Okay,
next year, geometry, like Ms. Harrison was saying, you will have to use quadratics at times, but it's not going to be like, you have to learn quadratics. It's more like you have to use what you learned with quadratics. So this is a really good idea. And I wanted to ask Ms. Harrison, we started quadratics 2 weeks before the shutdown, right?
Yes, we started the square rooting and graphing and parent function and all of that.
So I'm supposed to create a slide that will help me with next year's algebra 2. So for a cheat sheet.
So it's for just quadratics though. Do you remember like 2 weeks before the shutdown how we started quadratics and we looked at the parabola and we looked at where it crossed the x-axis?
Mm-hmm.
Okay, that is where we started with quadratics, and then we started learning how to solve them through different methods. And so this cheat sheet that you're making is only about quadratics. So a good place to start would be that picture that Ms. Harrison just drew. And then you can, write down all the ways to solve them. And I think that's what we're going to be doing today during our Zoom session is going through those things. So what a good idea would be to take a few notes today while we're doing this, and you can already have kind of a rough draft of your cheat sheet made, and then it'll be really easy from that.
Mm-hmm.
Okay. So that square root on the paper, is that a parabola?
This right here?
Yeah.
So do you think it's a parabola?
Well, I think that x2 equals y, so that's why I'm asking.
So is that x2 or x raised to the second power?
X raised to the second power. I just said 2 because it's easier. Sorry.
Yep, x squared. And so since it's an x squared, what do we know about this type of function?
Not much. My brain, it's been a while.
I understand. Somebody help Cameron out. What's the degree of the function? How do you find the degree?
It's the exponent. So it's the
exponent.
The biggest exponent that you see?
The 49.
All right, so that's just a constant number. The exponent is that little one.
The x raised by the power of 2.
So that 2, like raised to the power, that's always your exponent, that little number beside it.
And since it's raised to the power of 2, we know that it is a quadratic because that's the highest exponent it has. And so it is going to be some form of parabola like this, some form of a parabola. The first step we're going to do is look and see how we can solve this by square rooting. And so if we're going to solve by square rooting, we need to move this 49 to the other side. So how would we do that?
One sec, I'm working on something that involves this, don't worry.
Cayman, what do you think? How can we solve this?
Cayman.
Add 49 to the other side.
Exactly.
Oh,
Once we do that, what are we going to get on the left side? What are we left with?
X squared.
And then on the right side, Brandon?
$49.
Mm-hmm. Now, what is the inverse operation for squaring?
You use the square root on the x by the power of 2, and then you use the square root on 49,
Yes.
and that gets rid of the 2,
Mm-hmm.
and then it will just be x equals the square root of 49, I think. That'll just 49, or square root of it. Like I
So
said, it's been a while.
what is the square root of 49? Is that a perfect square?
No, I think it's uneven.
So perfect squares can be uneven.
Oh,
Let's look. So let's see, where's our square root button?
green. You'll have to use the second button.
A second square root 49.
7. Yeah.
So it is a perfect square. And is it just 7? What goes right here? Do y'all remember?
Why?
So positive 7 times positive 7 is equal to what?
Negative.
2 positives multiplied together.
Negative 49. Because you're timing is 7.
So when you multiply a positive times a positive, what do you get?
A negative.
No. When you multiply a positive times a positive,
Oh, you get a positive. Sorry.
that's all right. Now when you multiply a negative 7 times a negative 7, what do you get?
A positive.
Yeah, positive. So we have to put our plus and minus right there because we know that it could be either positive 7 times positive 7 or negative 7 times negative 7 to get that positive 49. So we have to add our plus and minus. So with that being said, I'm going to go over to Desmos and see what this looks like when we're graphing. So our graph, we've got x is, let me pull Desmos up for you. So do you see my screen with Desmos now?
Yep.
All right, so x minus, or x squared minus 49, and it gives me this parabola. And so I'm going to zoom out a little bit. What is my x equal when y equals 0?
I'm writing something.
What do you think, Brandon?
What was the question?
What is my x equal when y equals 0?
When y equals 7, -7.
And
Uh, I can't see the other one. One sec. I need to move something. 7, -7 and +7.
exactly. So that's what when we're solving for quadratics, we are solving for basically what does x equal when y equals 0. So that's essentially what we're solving for, is what does x, what's another way we could say that? Where does it cross which axis?
It crosses the x-axis at 7, at this negative and +7.
So that's another way we could say what we're solving for is where does the function cross the x-axis? And it crosses the x-axis at -7 and +7. So in graphing this function, we've seen not only solving by square root, but we've also seen how we can solve by graphing, just with using Desmos. And we'll continue to look at the graph of every one that we solve. But Desmos.com, you can see the graph. Another way that we learn to solve quadratics is by factoring. And this is when we did our puzzle. Do you remember? Yes? Maybe no?
Kind of.
So what about x squared minus 5x minus 14 equals 0?
Miss Harrison, can we see what you're writing on so that they can see the puzzle that you're drawing?
Yes, ma'am. I was still on Desmos. Better?
Yes.
All right. So what about x squared minus 5x minus 14 equals 0? We remember from our puzzle that we need to know what multiplies together gets the 14, -14, and what can we add together to get a -5. And so that's when we're going to look at the factors of a -14. So -14, we know 1 and 14. What's another one? Will 2 go into 14?
Yes.
2 times what equals 14?
7.
7. And we know that we want to add them together to get a negative. So which one's going to be negative? Our smaller number or our bigger number? If we want the result to be a negative, then which one do we want bigger? The smaller number or the bigger number?
The smaller one,
Okay, let's try that.
I think.
So
I'm
if,
only guessing.
so if the 2 is negative, what is negative 2 plus 7?
Oh. -2 plus 7?
Mm-hmm.
I thought we were timesing. I thought we were using multiplication, sorry. No, it'd be 7.
Puzzle, you have to do both. So you multiply to get that C, you multiply to get -14. But those numbers that you multiply also have to add to give you that B term, that -5. So you've got to find two things that work for both.
So, would they both have to be negative?
If you multiply two negatives together, would you get a negative number out?
No.
No. So that means only one of them has to be negative to create that -14.
So, I was right when I chose 2. The
Well,
-2.
now consider the adding part. -2 plus 7. Does that give us the -5 that we need?
No, it is. I'm 5. It's 5. My brain isn't working.
Okay. So if you put your negative on the bigger number, then your answer when you add will be negative. So instead of a -2, where should the negative go?
It would be a -5.
Right, and we had to put that negative on what number to make that?
The 7.
Good job.
Does that make sense, Brandon, Cayman?
Yeah, I get it.
Okay.
Yes.
So now we know what our factors are, so we can put it in our factored form. X plus 2 times x minus 7 is equal to 0. And how do we solve from here? It
So we
has
solve well.
from here. It has to do with the zero product property. Do you remember?
One sec. Oh, it would be 2 times x, then 2 times 7, then x times x, then x times 7, I think.
So you're talking about foiling it out when we would break it, when we would expand it, but we're actually working backwards. So we went from when it was expanded to factoring, and now to factor, we have to break it apart. Remember, with the zero product property, we know that when we multiply these two things together, we get 0. So one of them has to equal 0, but we don't know which one. And so to solve a quadratic, you set both of them equal to 0, and it becomes a one-step equation. So what is x plus 2 equals 0?
X plus 2 equals 0. X plus -2 equals 0.
So how would you solve this? X plus 2 equals 0. You would subtract what?
2.
Yep. And so
Then you'd add it to the 0.
would you add it? Because when you subtract on one side, what do you have to do to the other?
Sorry, you would put it where the 0 is. You would -2 from the 0, sorry.
And that would be what?
-2.
Yes. And then on this one, how would you solve this? X minus 7 equals 0.
X, 7 plus -7 plus 7, and then you'd add 7 to the other side.
So X would equal what?
7.
Perfect. And now let's see if that holds true on our graph with what we started with. We started with x squared minus 5x minus 14. And if this is true, then where should this function cross the x-axis?
-2 and +7.
Yeah, and let's look. Does it cross at -2?
Yes.
Does it cross at +7?
Yes.
Yeah. So there you go. That's an excellent way to check your work. So you might say, well, Miss Harrison, why can't I just graph it all the time? Because you're going to be expected to be able to factor, be able to solve by square rooting, and show your work. And so when you're asked to show your work, you're not going to be able to graph it. And then you're going to have to be able to show how you factored it out or how you solved it by square rooting. Are there any questions?
Oh,
Oh, good, Brandon. Good luck on your driving test.
I didn't know he was 16.
Good luck.
Good luck.
Bye, Brandon. Have a good day.
My sister's gonna get holes soon. Wait, I thought you didn't have to do the driving tests right now. My sister got her driver's license over the internet while doing a test.
It might be an online test that they're taking now.
Yeah, that's what she did.
Yep.
Yeah, it's coming in probably like 20 days now. And she's doing another online test that she needs 30 hours on.
Cool. All right, last one, guys. What's the one thing that we did recently that we haven't done yet?
Anything? I don't know. Oh, quadratics.
Very good. But okay, what was another way to learn to solve? Second one. Thing is,
Do you remember when we were singing a song?
No, I don't. Sorry.
you need to sing it.
You put on the paper.
I guess we do need to sing it again. Are y'all going to help us?
Just let me finish writing this down.
Cayman, did you say no?
Yes, no.
You don't want us to sing it. What is it called? Miss Harrison's already given you a really big hint on her paper.
I wrote it all down.
Good job, Brandon or Cameron. So what is the quadratic formula? Tell me.
I don't actually remember.
All right, I think we need to sing it, Miss Harrison.
I think so too. Minus b plus or minus the square root of plus or minus the square root of b squared minus 4ac b squared minus 4ac all over 2a all over 2a.
I think I remember it now.
All right, well now we're going to test this x squared minus 5x minus 14 equals 0 in our quadratic formula that we just solved by factoring to see if we get the same answer. So
Wait.
what is the standard form of a quadratic?
What was the question again?
Standard form of a quadratic.
Is it the thing above the x2 minus 5x? minus 14 equals 0.
That's the quadratic
Oh,
formula.
wait.
That's how you solve
AX by the power.
standard A, B, and C in it. Do you remember what that is? AX squared plus what?
AX squared plus Y.
No. So the next one, remember the exponents go down every time. So you still have like an X term, but what letter goes in front of the X?
A
So we've already used A first, and a good way to remember
plus
this is
B.
that it goes A, B, C in the
Yeah,
standard
so
form.
AX by the power of 2 plus B.
Yes, BX.
X by the power of 2.
So that one's just the power of 1. It's just an X. And then plus what letter?
C.
Yep, very good.
All right, there you go.
So is that quadratic she wrote down, is it in standard form?
Wait, it is or isn't?
We're asking. Do you think it is?
I assume that's standard form.
Can you check it? Can you look at it and tell?
I see the AX with the 2 over it, plus the BX and the CX, and since you say quadratic form is basically kind of like the alphabet, and since all 3 of them are vowel, I assume that is the standard form. I don't know how to really check it.
Okay, so you know how it says, let me see if I can write on this. So this AX squared here. Oh, let me change my color. Can't really see it. So check over here. Do you have an AX squared?
Yes. Well, actually,
Okay,
no.
and
Oh, you were asking to check the x2 plus 5x. I thought you were asking me to check the standard form.
so you do have to use a standard form, just
No,
check
but
and make
I
sure
thought
that.
I thought you were asking me to check the standard form that you wrote on the paper. Not that.
Gotcha.
That's why I was confused.
Well-
No, it doesn't have the A, the B, or the C in the problem, but it's probably would the 5 be the B and the 14 be the C?
Very, very good. Okay. You're on the right track. So do you see the negatives out front?
What?
You would actually have to be at 5 since it's got a negative in front of there. And then C would have to be negative 14.
Yeah.
That negative out front. So you got to see that there is actually an A. It's not there. It's understood. What does that mean? The A?
So the A is there. It's understood that it's there. And then you said something else about.
What number is that? If it's an understood number right there, you don't have to write it.
Okay, so it's understood that's there, so we don't have to write it.
Okay, it's a number.
What
So-
number is it?
What number could you multiply by something and it wouldn't change it?
Some 0? What?
That would make it a 0. Multiply by it.
Wait, we're talking about division?
Talking about multiplication.
Multiplication?
Cameron, what number can you multiply by anything and it's still the same number? So what can you multiply by 4 that would still equal 4?
Oh, 1.
So the A is a 1. It's understood. We don't have to write it. So now that we have our A, B, and C, we can plug it in to our quadratic formula. And so we have minus, and then what is our B again?
-5.
Mm-hmm. Here's that plus or minus again. The square root of b squared minus 4 times a times c. All over what?
2a.
So that's going to be 2 times our 1. And now we're just going to simplify. So what is a minus minus 5?
Minus minus 5?
Mm-hmm.
Minus minus 5. Wait, so we're adding a positive 5 to the negative 5, or?
So we're multiplying two negatives.
Okay,
Yeah.
okay, so they're both negative. Okay. Okay, that
So-
would be negative 10.
What is negative times negative?
Oh, negative times a negative?
Yep.
Mhm.
That would be a positive 10 then. No, that'd be a positive 25.
You're thinking about the second one. We're talking about this first. See this
Wait, are we
one
not
right there?
talking about 5?
We're talking about this first guy.
So you're having to distribute this negative.
Oh, negative 1 times negative 5. I mean, yeah, negative 5. That would be positive 5.
Yes.
I thought you
Plus,
were talking about a 5 and another 5 for some reason.
so that would be right here. That's your negative 5 times a negative 5. And what would that be?
What?
What is negative 5 squared?
That's that would be positive 25.
Cayman, what about negative 4 times 1?
Negative 4.
And then we're going to do, so negative 4 times what?
Negative 14.
And that gives us a positive 56. And then all over 2. So then we're going to simplify what's in the radical. So 56 plus 25 gives us an 81. So we've got 5 plus or minus the square root of 81 over 2. Now, is the square root of 81, is that a perfect square?
The what?
81, is that a perfect square? Do you remember that pink
9
sheet?
times 9.
Mm-hmm.
Yeah, so, yeah, it's a perfect square.
So now we're going to split it up. 5 plus 9 over 2, 5 minus 9 over 2. Why did we split it?
I'm still trying to write some of this stuff down. Why do we split what?
Why did we break it apart like this?
Because it's either positive or negative, and one of them has a minus and the other has a positive sign.
Exactly, that plus or minus right there. I think we lost Miss McMunn.
Oh,
So what is 5 plus 9?
5 plus 9, that's 14. It's 14.
Mm-hmm. I'm texting Miss McMunn to see what happened.
She's back.
Oh, she's back. There we go. So we have 14 over. We lost you.
I don't know what happened, but I'm back.
So 14 divided by 2 is what, Cayman?
I don't know.
You
7.
have $14. It's
Negative
okay. If you had
seven.
$14 to split between you and Cayman, how much would you get?
2.
Oh, so Cayman wants to get more money than you. You got to split it evenly between y'all.
Wait, I thought we were splitting $14.
Exactly. So if you split 14, how much?
He
would
said
you get?
2.
Because he wants you to get $2 for him to get $12. So let's
Oh, I
split it
thought he was
evenly.
talking about how much money he would be getting, and I was confused.
No, each of you should get $7 apiece.
That's not how that works. I get more. He gets less.
What is 5 minus 9?
Negative.
Negative 4.
Yeah,
Divided by 2?
my brain hasn't been working lately.
What is negative 4?
2.
Yeah, negative 2. So what we solved for is x equals 7, x equals negative 2. And is that what we found last time?
Yes.
X equals negative 2, x equals negative 7.
Positive 7.
Positive 7. Yes, ma'am. Are there any questions?
Not really.
So do you think that you can use everything that we've talked about today to complete this project?
The project is that this piece of paper is supposed to help us in the beginning of Algebra 2, or the
Pretty
other thing you talked about?
Pretty much. So this needs to be as detailed as possible so that you're going to go a whole year in math before you really start solving quadratics again. You're going to use, like Miss McMunn said, you're going to use some.
This is pretty detailed.
Yep. But you might want to include step-by-step explanations.